right. I'm ready for you guys. Who's got some questions they want to ask? On the calculator? Okay. So if you wanted to do like 5 to the 4th, I'll type the 5, and then I'm going to use this little caret button above the division sign. That'll put the superscript on there so I can type in then the number 4. And now that I'm ready to get back out of the exponent, I can just use the right arrow, and then I could do like a +1 or whatever after it. Okay. You're welcome. Jane?
Yeah.
I don't have an answer key written out, but I'd be happy to talk about stuff if you wanted to talk about some stuff. Sure. Okay. So part A should be pretty easy, right? Just whether it's a function, which the answer to this should definitely be no. Right? There's lots of vertical line tests. Oh, I'm sorry. Number 1, I was looking at the graph for number 2. Ha! Excuse me. So what I would do is I would start by rewriting this equation so that it's in a y equals form, where it's the x is kind of written as the independent, or the x is written as the independent variable, so it's a little easier to interpret what's going on. Is that okay there, Jane? So I'll subtract the x over, and then square root both sides. When we square root both sides of the equation, we have to remember that we get a plus or minus, which now indicates to me that we're probably looking at something a little fishy going on here. So for example, if x is equal to -1, then y would be plus or minus the square root of 2. Okay there? So that's definitely not a function, right? Because I have one x value that has 2 y values. Are you happy with that? So in general, if you have just an equation, the first thing I'd want to do is try to rearrange things to get the y by itself. And then I can play around with it a little bit and see if there's an x I can pick where I get more than one y. The case where that'll happen more than often is just because you get a plus or minus somewhere. Is that okay there?
Yeah.
Okay, so that's part A and B. C asks for the domain and range. So the domain here, well, hold on a second. Now that I look at this, oh yeah, I mean, it's still not a function. This is actually not a valid, this is not a counterexample though. Why is that a problem? The y's need to be coming from the integers. I have an irrational number there for my y. So what would be a better example here would be like y equals -2. Or y equals +2. In each case, if x is -3, both of those satisfy the equation, right? Because I'd have 4 minus 3 gives me 1. Okay with that? Okay. And the domain and range, I mean, it's right there, right? It just, the domain is the integers and the range is the integers because the x and y's have to come out of the integers. Is that, you're okay with that? I got carried away there and I didn't finish reading that. You know? That ever happened to you? You get excited to do the problem, you don't finish reading the whole thing? Some people say yes. Maybe not you. Mia. Oh, I would just do this. Yeah, I would just say domain is this and range is this. Yep. So again, all these kinds of questions are great kinds of questions. Some of these things I put on here were very tricky, right? And that's okay. Again, I would expect the hardest problems you'll see would be things in the homework versus the test, right? The test problems should be much easier in comparison to the homework problems, or at least more familiar. Like some of these things I gave you were definitely kind of unfamiliar situations, where had kind of a lot of things going on, and that's okay. That's why we wanted to talk about them. It's Joe's, yeah.
So number 2.
Like
I understand. Like do we have to figure out both of the.
Yep. So that's all part of the same function. This is actually called an elliptical curve, is what this is called. It's actually a very important kind of mathematical. Depending on how you're defining it, we can define it still as a function, even though it fails a vertical line test. But you won't know that until next year when you take honors trig and pre-calc, because we can kind of alter that way we're defining these things and still make that a function. But the cryptography that like your cell phone uses to like encrypt your email, so like somebody can't intercept your email and read it, is based on doing mathematics on an elliptical curve. It involves like how do we translate from one point to another point on this curve. And that's the math problem that's built into the encryption. The issue is that if you don't have like the encryption key from the outside observer, it's like an impossibly difficult problem to solve, and you're only getting the key that's the sender and the recipient. So anyways, that's a total aside from what's going on here. But yeah, the blob and the v are both parts of the same function. Did you have more? Just checking. Okay. Sydney. Ella. Sydney's in front of you. Hi, Sydney. You guys are both wearing flowers on your mask, and I got confused.
For number 2, I know it's not a function
Good. Okay. So here I'm going to have to do a little bit of estimating on some of the points, at least for the domain. The range I don't have to worry about because I have a connected part of the graph where the arrow points up and the arrow points down. So the range is just going to be all real numbers there. This blobby part doesn't really matter for the range. Is that okay, Ella? Okay. So let's worry about the domain. And the domain, I'm going to have two pieces. I'm going to have a piece from the blobby part and then a piece from the V, because those two parts aren't connected and there's x values missing in between the two parts. Is that okay? Okay. So let's estimate this at like, I don't know, negative 1.8. I'm going to estimate this at like positive 0.4. Probably not. Probably positive 0.5. And that looks like maybe 1. Again, these numbers, as long as they're reasonable, like I included some scales, but not enough scale to tell specifically what that should be. And I didn't label the points or anything because I wanted you to kind of think about what was important and not important. So I would do that. And again, if your endpoints on those things differed by a little bit from mine, that's not a big deal. Now, if you called the negative 1.8 like negative 3 or something, I would mark that wrong because it's clearly not negative 3, right? It's less or bigger than negative 2. Or if you call it a positive number, like I'd mark that wrong. But if you had almost anything in between negative 2 and positive or negative 1, I probably would have said okay. Joe?
So I understand like the negative 1.8, 1.5.
Mm-hmm.
So 1 to positive 3. Why is it positive?
Because both of these arrows are going to the right. And what we care about is the x coordinate, right? Since we're doing a domain. Is that okay? So that's maybe the easy way to think about it, is to label the arrows with like positive infinity, comma, positive infinity, or negative infinity, or whatever it is. And then if you're talking about domain or range, you're looking at either the x or y coordinate respectively. Does that feel okay? Mia?
Like for this banana question, the one theory that the transformation. If there's a vertical stretch, do they only multiply that factor by the y value? Or do they
Correct.
have
Just the y value.
and then the horizontal is just the x?
Correct. Yep. Ella, are you happy with? Okay. What else can we talk about here? I'm happy to do some more. Natalie?
Can you go over boundary shows how to find scale with
Sure.
our
Of course. Do you want to just use one of the ones from the review here, Natalie? Is that okay with you? Sure. Happily. Okay. So first thing I need to do is type the equation that I'm looking for the extrema on into my graphing calculator. So after I've turned it on, I'm going to just press the y equals button. And then I would start by clearing out anything that's in there and typing in the equation on exactly as it appears on my sheet of paper. So I've already done that here because this was not the only class I gave this problem to and not the only person that's asked about it. So I'm glad you are, because this is always worth reviewing because most of us are brand new at using these graphing calculators. So we're still kind of getting used to the menus and the buttons and where everything's at and how to use it and all that, which is perfectly fine. Happy to do these again. You got it cleared out and typed in then, Natalie? Okay. The next thing I'm going to do is press the zoom button, here on the top row, and pick Z standard. And when I look at my graph, well, it's hard to kind of tell, right? Maybe there's a maximum here and maybe there's a minimum there, but it's kind of far away. It'd be helpful if I could zoom this in and get a better look. Do you agree with that? And it's possible that you tried it still on this setting and you got it to find a max and a min. That's certainly possible. It's not impossible by any means. If you were careful and paid attention to the points when you're doing a left-bound, right-bound guess, you might have been able to get it to go. But let's kind of adjust the window here a little bit and get a better picture. So if there are any extrema, they got to be going on kind of in this little section of the graph, right? So if I were to estimate the x values that I'd be interested in, I might go from maybe starting at -5 and going to 0. Does that seem like a reasonable range of x's that I'd be concerned with? And then for y's, well, maybe just from -1 to +1 would be the range of y values that I'd be interested in. And if I get that little rectangle with the, covering those values, I should get a pretty good picture of what's going on. So I'm going to manually select my window now using what we just observed there. Now, I picked these numbers. I guesstimated these. Like I looked at the picture, I made a reasonable guess. But if you had picked the y's from like -3 to +3, it's going to be fine. Or if you're x, you just need to be able to see the extreme a little bit better. So I'll tell you what I would have guesstimated, but your guesstimate might be somewhere a little bit different, and it's going to be fine. And if it's not fine, you'll be like, that doesn't really look what I expected it to. Maybe and you can go back to the Zoom standard and like really look at what you typed in again and be like, oh, yeah, I did +5 instead of -5 or something, Anyway, so I'm going to press the window button. And the x min, I'm going to go -5. And the x max, I'm going to pick 0. So this is going to just graph the part of the x-axis going from -5 to 0. And then for the y min and y max, I'm going to pick -1 and +1 for the y min, and then +1 for the y max. And I'm going to ignore everything else, whatever it was at before, even if it's different than what you're seeing on my calculator, leave it alone. So the only things we change were the x min, the x max, the y min, and the y max. Okay. Once you've done that, let's hit graph, and it'll take us back to the graph, but with our new window. And here we have a much better picture where we can clearly see what's going on. Does that work for you, Natalie? Okay. So now that I have a very good picture of what's going on, let's go ahead and find that maximum minimum, because I can see now that there's clearly just one local max and one local min. Everybody agree? Okay. So let's find the local maximum first. So that spot right there. I'm going to press second and then the trace button. From this menu, I'm going to select the maximum command. And now the calculator is going to ask me 3 questions. It's going to ask me left bound, right bound, and guess. So right now we're on the left bound. So I just need to take this cursor and move it somewhere to the left of what appears to be that maximum. So anywhere kind of on the left over here would be fine. So that spot I'm at, I'll just press enter. Now it asks for a right bound. So I'll just move my graph to the right. Really anywhere over here is going to be fine. So that looks good. I'll press enter. And then a guess, you don't have to move it at all, just guess wherever you're at. And it spits out my answer here. So I would say rounded to 3 decimal places, -2.577, comma 0.385. As my maximum, my local maximum. Okay with that, Natalie? Okay. Yes, Joe?
How do you use the
So you need to press second and then trace. And then select the maximum command. And then you need to do left bound, right bound, and guess. So you need to give the calculator 3 points. One to the left of where the maximum is, another one to the right of it, and then a guess somewhere in between. And then it should spit out that value at the bottom for you. Okay, want to try to do the minimum? Sure. So do second and trace. This time we'll choose the minimum. Left bound. That seems fine. Right bound, got some buttons to press here. There we go. And then a guess. So here I get -1.423, comma -0.385. Does that feel okay, Natalie? Okay. And Jane, that's probably helpful for double checking, right? If you're looking for answers. Yeah, so they'd be like an ordered pair.
Yeah.
So like.
But you don't have to correct.
No. So this is the brackets is for an interval, right? That's a range of x values or y values, I guess. An ordered pair is just an ordered pair. So like, I don't even remember what it was. Negative. So you just do something like that. Mia? You don't need to, because when you go and graph again, you'll do the zoom standard, which automatically will reset them back to that the window you had before. So that's why I like to use that as rather than just typing the thing and pressing graph, because then you end up, if you changed your window before, like you have something goofy and it doesn't look right. If you just go zoom standard, every time to graph, you usually get a decent overall picture of what's going on. And then you can adjust your window from there manually. Is usually what I think is the easiest way to go about doing it. So you don't need to worry about resetting your window in between. The zoom standard will take care of that for us. What else do you guys want to talk about? Jane?
So for the transformations, will we have to memorize like reflection versus stretch by factor?
Yeah, so I would say that you should be able to do that. Here's what I'll tell you. I will give you this part for now. I'll give you that. But you'll have to remember what A, B, H, and K do individually. Does that seem fair? So I'll meet you halfway on that. That being said, I would also, for a graphing part, I would give you this thing if you needed it. Okay? So I'll give you those two so you don't have to memorize the symbols. We'll take it one step at a time. We'll memorize what the A, B, H, and K do, and then I'll give you this part. Next time I might expect you to remember this part, but this first time through I'll give you this. Joe? Sure. Okay. So, first thing I want to do is I'm going to use this to identify the values for A, B, H, and K. So this I can see pretty clearly as my A. Now if I go to look for a 1 over B, I notice that I have a coefficient in front of my x, right? But what number is there that we just didn't write down? A 1, which we can write as the fraction 1 over 1, right? So that just tells me B is 1. And then I have x minus 1. So that tells me the h is 1. And then I have nothing on the outside here. So what am I adding if there's nothing? 0. Good with that? Okay. So now I'll just go by one with each one of these values and just describe what they do. So since the A is positive, I have no reflection on the x. And since the magnitude of A is greater than 1, I have a vertical 3 over 2, or you could call it 1.5 if you wanted. It doesn't really matter. Since the B is positive, we have no reflection across the y. And since the B is 1, we also have no horizontal dilation. Since the h is positive, and since k is 0, we have no vertical translation. Now on a test or whatever, I wouldn't require that you write down, like, because of this it does nothing. I would just need you to have included those two pieces where something is, they're changing. Is that okay with you guys? Joe, does that feel okay? Okay. So again, I think it's helpful early on that we're writing out, this is the value, so I know it does, this, even if the thing it's doing is nothing, because we're still getting used to the list and the criteria. But I would not require you to state that like nothing happens if nothing is happening. But I think like thinking about, okay, there's 6 things, and making sure you kind of think about all 6 of them each time is helpful, at least in terms of like, did I get them all? Did I remember to do everything? Because this is the first time you're probably doing this. So I'll write it out for a while. I would not require you to. Jane. 13? Sure. So we'll start the same way. So we have a negative sign out front. So that I know that's the same thing as multiplying by -1, right? So my a is -1. And again, the same, we have just a 1x, so just like before, I'll rewrite that as 1/1. And then I have nothing added or subtracted from the x, which is the same thing as just subtracting 0, right? And I have the +3 on the outside. So b is 1, h is 0. So if we write down just what things are, since the a is negative, we have a reflection on the x-axis. The a, though, is 1, which doesn't do anything. So you could write that down, or you could not write that down. Either is okay. B is, yes, Jane? So B does the y-axis. Yep. Since the B is positive, we don't have a reflection across the y. And because the magnitude of B is 1, we don't have any horizontal dilation. So you could write those 2 things down, or you could not. Either is okay. The h is 0, which means you're not shifting left or right any. So you could write down that there's no horizontal translation, or you could skip it. And because the k is positive, we know we're going to go up 3 units. So this would be all I would require to see there. If you included the other things, that would be okay. But you didn't need to. So I did an example where where I wrote them down, and one where I didn't write everything down, and either is fine. Joe? Uh-huh. Yeah, sorry. Oh, okay. Number 11. 11 is. Oh, did I miss number stuff? I see. Okay. I'll have to try to remember to change that. All right. So number 11 is what we're working on. The first thing I would do is I'd want to rewrite so that it's in, this form, so that I can easily identify the values for A, H, or A, B, H, and K. Questions on what I did, what I did there, Joe? Is that okay? So doing that, I can see that A is 3/2, B is 1, H is -2, and K is 0. Okay. Now that I have those, I can write my transformation. And as a reminder, like I mentioned to Jane, this is an equation that I would give you. You don't need to memorize this. You just need to know what to do with it. So plug those things in. And now what I'm going to do is I'm just going to use the 3 key points for my function. And I'm going to plug those in for x and y. So -4, -5, 2, 1, and then 4, -1. So -4 minus 2 is -6. -5, 3 over 2 is -7.5. 2 minus 2 is 0. And then 1.5 times 1 is 1.5. 4 minus 2 is 2. And -1 times 1.5 is -1.5. So those are my 3 points that I'm going to graph. So if I go back to my picture then, graph -6, -7.5, which I guess would be off the graph somewhere. 0, 1.5, be like there. And then 2, -1.5 would be like there. So it would look kind of like that. Is that okay, Joe? Do you feel better about doing that then?
Yeah, I thought something really different.
Oh, okay. Jane? 7? Sure. Anybody else with a question on 11 before I move? Okay. We don't have the page for 7 yet. Ah, I see. Okay, what do we need? Domain, range, intervals. There. Okay. So let's zoom in here and get a good look at what's going on. All right. So domain. When I look at this, the first thing I notice is that the graph isn't connected, right? That there's separate, distinct pieces. So if I'm doing domain, the first thing I want to check is to see if, do all of these, are there any overlapping x coordinates? So if I look, I see there's gaps between each of these little u's where no x coordinates are shared, right? So that tells me that each one of these u's is going to need its own separate interval to describe it. So starting with this one, I'm going from -7. And I'm using brackets because I can see I have a filled in point that has the x coordinate -7 and the y or the x coordinate -6. You okay with that, Jane? Okay. And then I'll just do a union for each one of these. Okay. For the range, what I'm going to do is I'm going to check to see if I have overlapping y coordinates. And here I do, right? So like this section here, well, here overlaps with these first two u's, right? And each consecutive one overlaps with the previous one, right? So that tells me I can write the range just using one interval. I could write it as a bunch of separate ones, but it's way less work to just write one interval. So that's what I'm going to do. So that interval is going to have a smallest y coordinate here at, I don't know, something. Looks like -5 though. And its highest x coordinate is, looks like 8, 4. So I'm going to have -5 to 4. And it appears I have a point with each of those x, or each of those y coordinates, so we'll use brackets there. Does that feel okay? Okay. All right. For positive, -0, increasing, decreasing constant, because the domain I had to treat as separate intervals. I know I'm going to have to treat each one of those as separate intervals because each of those intervals are described with the x coordinates. So positive, -0, increasing, decreasing constant are still going to need intervals, or separate intervals for each section like we had before. So for positive, I have that part, all of that, all of that, all of that. You agree? Okay. So for positive, it looks like I have 1 to, I don't know, like 1.2. Now notice that I used a bracket on 1 because that point with the x-coordinate 1 is above the x-axis. And then it looks like, I don't know, 1.8 to 2. Now 1.8 is going to get a parenthesis because that's on the x-axis, but the 2 would get a bracket because it's above. And then I have 3, 4, and then 7, 8, both with brackets. And then for the negative parts, I have this, 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 and that. So again, these first parts are all going to get brackets because all of those, the whole shebang is below the x-axis there. Until we get to -1, 0, right? That one needs parentheses on it because those two endpoints are on the x-axis. And then 1.2 to 1.8. Those were the values I think I used. And those also get parentheses because those are on the x-axis. And the 0 section is just 4 distinct points, right? These 4 right there. So -1, 0, 1.2, and 1.8. Okay with that, Jane? Okay. So increasing, decreasing constant will probably depend a little bit based on your estimates. So like for this first one, let's do the increasings first, I guess. So we're increasing just the second half of our u's, right? And I'm just going to assume that the bottom of that u is like the midpoint there. So that first one is halfway in between -7 and -6, so we'll call it -6.5. Would be what I think would be a natural estimate on that. It looks like about that. You guys agree? So -6.5 to 7. Oops. 6.5 to 7 union. And then -5.5. Look. -6.5 to -6. 5.5 to -5. Nope. Okay, so that's -4.5 there, genius. Going to -4. You ever just make like a whole mess out of things? Yes, this is what I'm doing right now. I'm trying not to, guys, but like sometimes it just happens. You know, the best laid plans of mice and men and all that. And you'll notice that I'm using all parentheses here, because remember that for the constant, we're always using parentheses. And that had to do with the definition, or the way we define these. And then decreasing, we'll do the same thing. So we'll have just the other end. And there's no constants on this because there's no flat parts. What else did I ask you to do on this? End behavior. Okay, so are there arrows at the end of this graph? No, we have distinct points. So can there be end behavior? No. We need the arrows at the end to do any end behavior stuff. So this will just be, yes, sir.
Will there be something that's wrong?
Oh, goodness, no. Like this is, just was it was interesting because you really had to think about it and make sure you understood what was going on to be able to write this out. But this is like, I could do 3 U's and you'd get the picture on the test, and it'd be much shorter, right? That would be much more likely scenarios. You get something similar to this, but like 3 distinct parts instead of whatever, there's 10 there or something, which just makes it kind of a pain in the butt. Yes.
Number 5.
Yes. Emma.
Yes.
Yes. Okay. All right. So this one, the graph is leaving the edge. So this one depends a little bit on what you're interpreting the arrows doing. Now, this is a poorly written question on my part because I don't think upon review that I gave you enough information for you to decide what those arrows would be doing. I'll tell you what I had intended you to think was that they just kept doing this. Now, was it reasonable for me to make this assumption that you would have assumed it just kept doing this? Probably not, based on what I've given you here. So if you didn't think that, that's my fault, not yours, because I just wasn't clear enough about it. So whatever you wrote here, as long as it was like reasonable, would be fine. But let's do it the way that I had intended you to interpret this. Is that okay, Emma?
Yeah.
Okay. All right. So the domain, this is continuous, right? Because it's connected the whole way through. And it goes all the way to the right, and all the way to the left, and all the way to the right. So the domain is just going to be negative infinity to positive infinity. Yes. Absolutely. Yeah, go ahead and check. Important that you track that down, you know. The range, well, it seems like there's an absolute low point, right? Which looks like it happens at -1. And an absolute highest point looks like it happens at +1. You guys agree with that? And there is a point, or lots of points actually, that have the x or the y coordinate -1. So we'll use a bracket. And there's lots of points that have the y coordinate +1. So use a bracket. Is that okay, everybody? Emma, you're good?
Yeah.
Okay. So there's my domain and range. Now, the tricky part becomes these intervals here, because how many positive intervals are there going to be? Infinitely many, right? Because it keeps doing this like up and down the whole time. So how am I going to do that? Well, this is the way that I think is the easiest way to do that. I'm going to do a set of intervals. So one positive interval appears to be this here. I'm going to say that this point is 3.1, 0. Since this spot is a little bit after 6, I assume that that spot halfway is a little bit after 3. Again, estimates will vary. So one interval is 0 to 3.1, right? And if I take 0, the next start happens a little bit after 6, right? So I'm actually going to change this, and I'm going to write it as 0 plus 6.2k, and then 3.1 plus 6.2k. Or x or y, because it wasn't like a canonical x or y variable, because we're talking about points, and I think it would be confusing to use my variable name as a same name for a point. So I just chose k. You could choose z or c or whatever. And we need to say something about k now. So k needs to be a whole number, positive or negative, so that would be an integer. So when k is 0, all we have is that section there, right? When k is 1, we'd have that piece over there. When k is negative 1, we'd have that piece back there. When k is negative 10,000, we'd have some piece way over here. But we're going to describe all of those positive sections that way. Now, would I expect you to have come up with that notation all on your own? Probably not. Okay, that seems unlikely that you would have done that all on your own. But after seeing me the way I did it, it's like, it's pretty clever, right? It's a compact way, describes all the infinitely many. So would I expect you to be able to do this again on a test? Oh, probably not something this complicated. But is it, like an unreasonable assumption that if you saw another homework problem that involved doing something like this, you probably wouldn't look at it with like cross-eyed at it again. But this was very tricky to come up with on your own, right? Not obvious, not an obvious thing to do. And that's okay if you struggled on doing this. That's the point. The homework is going to be harder than the tests, pretty much always, or at least the level of difficulty of the questions. Now, you can make the test plenty hard by freaking out and stuff. Any luck?
No.
Uh-oh.
They left it at home.
Oh, boy.
They never leave it at home. I always bring it.
Well, not anymore. Your always streak is over.
This is the first time this year I haven't brought it. I'm usually so good about bringing it.
I know. It happens. Okay. For the negative part, I'm going to choose this one as my base. It doesn't really matter because we're adding that 6.2k to it. So that looks like negative 3.1 to 0. But we need to add plus 6.2k's to each of those. Are we okay there, Emma?
Yeah.
Okay. Everybody else that's following along, that's still kind of picking away at things, feel okay doing that? Okay. And then our zeros, we have a whole mess of these, right? So but they're points, they're singleton points. So again, I'm going to use the set builder notation. So I'm going to say the set of x is such that x is equal to, I'm going to pick one of them. I'm going to choose this one. And then I notice that basically every 3.1, I run into another. Is that okay? All right. And then the positive, negative, 0, or increasing, decreasing constant would be similar, right? Do we need to write out all those sets for you? I'm happy to do it, but if you don't, we can move on and talk about something else. I don't know if you're getting bored, if you want to see it done. Emma, where are you at?
You can do it.
Yeah, that's fine. I'm just checking. Again, I don't want to assume that it's easy or that you get it. I don't want to assume that it's hard. So I'm just going to ask before I go and do it. So increasing, we'll do that part first. So there's going to be my base increasing section. So that increasing section starts at, well, if it's halfway between 0 and negative 3.1, that would make it like negative 1.55. Similarly, that one's going to be positive 1.55. So just like before, I'm going to use the plus 6.2 Ks to describe every part, every positive part on that infinite set of, or I'm sorry, every increasing part on that set of infinite increasing parts. Very sneaky. And then decreasing, I don't know, let's use this one, I guess. So if that's 1.55 and we go 3.1 more, that makes this like 415. So 1.55 plus 6.25, or 6.2K to 415 plus 6.2K. And then constant are the flat sections, and there's no flat sections to this graph. And we still need to talk about the end behavior here. So this graph has arrows going on both ends of the graph, right? But are the arrows ever pointing to just like one thing? Sometimes they're pointing up, sometimes they're pointing down. It just keeps on doing that. So can we describe an end behavior? We cannot. This graph is called an oscillating graph. You'll see these a bunch next year in trig and pre-calc. Some of you may have recognized this one already. I don't know what kind of, if you came from integrated, you may have seen this already, or this particular graph already. I don't want to make any assumptions, so. Or maybe even you might have seen it without. I don't know. Maybe you got some dope parents that teach you cool math on the side. Okay. Any more? Happy to do some more. This is really all what I had budgeted for today, so keep them coming if you got them. Jane?
So for 4, did you put that into, like,
Yeah. So if I compare 4 and number 1, they're quite similar, right? But they're different in a very specific, exponents are reversed, right? So yeah, I would do exactly what you're starting to say, which is get the y by itself. It's exactly right. And I would think to myself, well, if I pick a value for x, is there any way I can get 2 different values for y? Not in the way it's currently written, right? Like if I pick x equals 1, well, I'm just going to get 0. If I pick x equals 4, well, I'm just going to get negative 15. Like there's no value for x that I can pick to get 2 separate y's. This should be a function. Alternatively, you could look at the graph for this, right? Yeah, that's a perfectly reasonable thing to do. Fire up your graphing calculator. Well, the issue with that is that it's when you get the y by itself, you have that plus or minus, and there's no plus minus command on your calculator. I'll show you what you can do in a second. But the bigger issue is that the x and y's are only coming from the integers. That's the bigger issue on your calculator. So here is this, and then if I just do zoom standard, there's my picture, And that certainly passes a vertical line test, and you can use that to do the domain and range if you wanted to. Certainly reasonable thing to do. Joe.
What would be an example of where, like, the y could get
Yeah, so if this was instead, you square root both sides and you get plus or minus 1 minus x. So if I pick x to be 0, I get y equals plus or minus 1. So that's 1x with 2 y's. That's not a function. So usually you need a plus or minus to show up, which means that the y value has to be an even exponent. Does that feel okay? Okay. Jane, now if we just leave off that x and y have to be integers here, what you can do on something like this, to deal with the plus or minus on your calculators, you can use two separate equations. So I'm going to do, in the first one, I'm going to do the square root of 1 minus x, where it's positive. And the other one, I'm going to do negative square root 1 minus x. So that's like the negative for the plus and minus. So I can do that. And if I looked at the graph of this, I'd have to treat these all as both curves as one graph. But this is what it's looking like. And that doesn't pass a vertical line test. Now the question becomes, can I find an x and y that are both integers? That's maybe not so trivial, but you can do what you can do if you press second and the graph button. Ooh, let me reset my table. So if I press second in window, this gives you the table setup. I just want it to start at 0. And if I press second in graph, what this is doing is giving me a list of the x value and then the y values for these. So all I need to do is scroll through and see if I can find an x where both the y, where everything is an integer. But this is one x with two separate y values. And as long as I can find one where everything is an integer, you know, even here would work, then I have my counterexample that way also. But you have to be a little bit careful about the integer part. But you could use your calculator to get it, but you have to be a little bit careful there with that one. Does that feel okay? Any better?
Yeah.
Okay. Some calculator tricks help, right? For 4? Okay. So if I remember the graph, it kind of looked like this, right? So I have negative infinity as this point, and then positive infinity, comma, negative infinity for that point, right? So the domain is just going to be negative with arrows at both ends. The range, the highest point is here, which I think would be 1, 0. And the lowest point would be either one of these. So the range would be 0 to negative infinity, where I have the bracket on the 0. Does that feel okay?
Yeah.
So again, like you could get that by just reading from the graph. You wouldn't have to monkey with that algebraically too much. And that would be my recommendation there on that one too, Jane. That's by far the easiest way to handle that, is to just translate it into a graph. Okay. Any others? Should we talk about test format for a minute here before we run out of time? And if there's more time and somebody else has a question that comes up, we can deal with that. Yeah, Friday, right? That's on the calendar, right? It was on the schedule for the week? Okay. Yeah, no, that's fine. I was gone yesterday and I have all these classes and it's hard. This class meets, I have an A day and B day, so it's hard to remember like which one is which. And I'm going to do my best that If it's not on the weekly agenda, then it's not happening that week for sure. But if it's on the agenda for that week, like that's what we're doing, unless like there's real extenuating circumstances or anything. So here's what I will say as far as the test format goes. I would say you'll have the same like style and type of questions as you saw from the review. There will be fewer of them, and I would say they will not be nearly as complicated. So like nothing wrong with number 3, right? Number 3 is pretty easy. You can certainly expect of this problem, like this set of directions, you'll have some problems that are like the level of difficulty of number 3. I think the graph for number 2 is not unreasonable. That would probably be as hard as I would get for this type of question. Okay? I would not give you something nearly as complicated as number 1. And I probably wouldn't give you something as complicated as number 4. Okay? I'd probably give you something that was a little bit more familiar from a function standpoint. Maddie, you had a question?
No, not really.
Okay. You should definitely expect one question where you have to use your calculator to find the maxes and mins. Very similar to like 8 and 9. I know I'm going out of order here because I pasted in the questions, or the pages out of order from when the questions came up, but that's, you guys will deal with it. I would expect probably at most one question, like 10 through 13. They're all about the same level of difficulty, right? You know what I mean, guys? You'd agree with that basically one of those is the same as any other one. If you can do one, you can do 10 of them. It doesn't really make much difference. You'll get one where you have to draw the graph similar to like 10 through 12. Now the starting graph will be different, but it'll be like a similar level of complexity where you have like 3 points you have to worry about or something. Like I'm not going to go bananas and have something with like 15 points on it. That just is a pain. Is that okay? And again, similar to the previous, like if you can do one of these, you can do 10 of them. Like they're all kind of the same, right? This section, these questions 5 through 7, I think questions of the caliber of 5 and 7 are far too difficult as test questions. I think that 6 would be a hard test question, but a reasonable one still. That's probably the maximal difficulty I would get on a question like this would be something like number 6. So if you felt okay there, I think you're probably fine. Now there's some tricky things about 6, but it's not like overwhelmingly tricky. The worst I would possibly do is put arrows at the ends so that you could actually do the end behavior part of it. Like that's the only more complicated a question like 6 would get. But I would probably have 1 or 2 of these, maximum of 3 of this type. But there's a lot you have to do, so it would depend on how complicated they got. If one of them was as hard as 6, you'd get 2. If they were all easier than 6, you might get 3. But there won't be any type of question that you haven't seen or in a style that wasn't on the review. So the questions will be similar to the questions on the review. Nothing on the hardest questions on the test will be easier than the hardest questions on the review, for sure. The number of questions on the test will be less than the number of questions on the review. In particular on stuff where it's like if you can do it once, you can do it 10 times. Joe.
So is it like the problem is wrong? Like wrong?
No, I would certainly give you partial credit. Some of these have a lot of things that I ask you to do. So let's say that you had like the domain question, right? Or some part of the question was a domain question. And your answer was 3 to positive infinity. And the correct answer was like 3 with a parenthesis instead of a bracket to positive infinity. If this was like a 2-point question, I would give this 1.5 out of 2. You know, or if you wrote, you know, or if you did something like you put brackets at both places, 1.5 out of 2. Or you just got confused on which one was which, still probably 1.5 out of 2. Even though technically 2 things wrong with it visually, I think it's the same mistake just done twice, right? It just, like, if you screwed up one of them, you knew one meant one and one meant the other. You just didn't know which one was which anymore. Like, it's still one mistake to me. Does this help in terms of like how I would grade stuff? So again, like, you're much better off trying to do it. Okay. Now, if your answer was, say, instead you did something like 3, 4, 5, 6, like this, you know, I'd give you at most 1 out of 2, maybe less. Since you don't have the correct format, because you don't have something infinite, you wrote something finite, is already at most half credit to me. But you did have the correct starting. So, and it is getting bigger, so you were looking at the right kind of part of the graph, but you used distinctly the wrong format, and your domain is absolutely wrong. That's probably like 1 out of 2. So these are like common things I see students make, just to give you a feel for like how picky I would be about stuff, or like how generous I am with the partial credits on things. So again, like, I'm usually looking at the quantity of the mistake and then the type of mistake. Like, is this a fundamental, like, I don't understand what I'm looking at or what the notation means? Or is this just like I goof something up? And it's a little bit hard on these ones where there's no work to show, right? But I would say, like, you know, on a question like, where are they? Down here. On a question like this, if you labeled the parts that were like positive, negative, increasing, decreasing, and stuff on the graph, I would at work shown. I would contribute that to partial credit. If you went by and labeled the parts so like visually you knew, and what you screwed up was the notation describing them, you know, like, I would probably count that as partial credit and give you something, even if you couldn't write an interval to save your life. You know, you knew what the terms meant. You just didn't know how to use the notation. I would probably give you half credit if everything was labeled perfectly, or at least some credit, even if you couldn't write any of the intervals. Does all that seem fair, reasonable? Okay.
It's not going to take the whole hour.
I wouldn't suspect it would, especially this first one. I don't think we've done a lot, but we haven't done anything that's tremendously time consuming. Like, it's nothing that it's like, ooh, this is like a, 5-minute solving problem here. Like, it's just like seeing, like, looking with your eyes and writing stuff down. Probably the most time consuming thing is the calculator question, where you have to find the maxes and mins. But like, if you know how to do that, it's really just like a minute or two once you're comfortable doing it. So this one I don't think it would take the whole hour. And whatever time's remaining, we'll just start on the next stuff. Does that feel okay to you guys? Okay. So I usually shoot when I'm constructing this for like 45 minutes to an hour is usually what I'm looking at in terms of when I'm writing a test. That's kind of my aim. Usually it'd been closer to 45. We have longer periods this year. I don't know that for a chapter like this there's any reason why I need more than 45 minutes worth of questions, because there's, like, it's either going to be too complicated to reasonably expect you to do in a test setting, or just like so long that it's asking you to do the same stuff over and over and over again, which again, like, I think is a bad test also. So, yeah.
Do you give extra credit on tests?
No, typically not. So, yeah. So there's that. Anybody else with questions on stuff? I think you guys asked most of the good stuff. What's up?
It's gonna be on paper, right?
Yeah, at least this time. We'll see, but I figure if we're all present, makes it much easier to justify test security if it's all on paper. You know, not that I don't trust you guys, but if you're writing it on the tablet and all your notes and everything are also on the tablet, it makes it awful tempting and difficult to both proctor. So I think it'll just be done on paper. So you should make sure you have your calculator with you. You definitely have to have a calculator that's working. You'll need like something to write with. I prefer that you use pencil, especially if you're kind of on the messier side. You might need to do some erasing. Probably won't be an issue on this one because there's no real calculations to do. But if you ever need like separate sheet of paper because you're just like a big writer and I routinely don't never give you individually enough space to do your stuff, you can always take some scrap paper and do your work separately or whatever. Mia? Absolutely not. Go do like, if you want to highlight things or use different colors to label things, if that helps you, go ahead and do it. No big deal. As long as it's clear, like what your answers are, whatever, I don't really care. So if it helps you, I welcome you to do that. Does that everybody feel okay in terms of what to expect? Hopefully a bit better than you maybe did walking into the room where some of us might have been a little freaked out from the study guide level of difficulty. But that's okay. Again, like I think we had a lot of good conversations and we got to ask a lot of the kinds of questions that you wouldn't answer if it was really easy. You got to ask all these kinds of great what-if questions and how do I think about this, or like, what does this even mean, or like, I didn't even know like how to interpret this or what I would even, how to approach something like this, and those are great things. Because the learning isn't just the test, right? Learning is the stuff in between the test. And there's a lot of learning that I'd love for you guys to do that is not reasonable to test, right? Because a lot of mathematics is just like being clever and problem solving that don't really lend itself well to test settings. Because it takes time and you have to think about it and you have to have some experience beforehand and have seen stuff before and like have a bag of tricks. And if you've seen it before, if you've never seen it before, it makes it unreasonable to do it on a test. If you have seen it before, it's not a very good trick to pull. So like that kind of work just kind of needs to be done in homework in a low stakes setting where you just get to kind of struggle at it for a little bit and then say, I don't know, we'll talk about it tomorrow, which is fine. That's what I want you to do. Okay? We feel good? We're good enough anyways? Okay. I'll settle for that. Thanks, guys. You have 3 tests in a row on Friday.
I have AP history, L&L, and then I have a class. I swear, if I have a test hard science,